how to prove that a quadrilateral is a parallelogram. So you have a cardstock that's going to turn into flashcards and then game pieces eventually, okay? But we don't want to cut them apart yet because we have a bunch of stuff that we need to add to it. But if you notice, when you create flashcards, on one side where we have a picture in the upper left corner, if you flip it over, it ends up being in the upper right corner. The back of it does, okay? So this is where you're going to be writing, is the upper right corner where it starts with parallelogram, okay? So part of being a geometry student and doing well in this class comes from the fact that you can see geometric hieroglyphics and you know what they mean, okay? We really have our own little language, our own little symbolism in this class that you don't necessarily have in other classes. So when we see something that looks like this picture in the upper left, what does that mean? It's a parallelogram. Why is it a parallelogram? Exactly. Both pairs of opposite sides are parallel, right? So that's what we're going to write in this first block. Both pairs of opposite sides are parallel. Okay? When you see those arrows, that means we've got parallel sides. So up here in this upper right block, both pairs of opposite sides are parallel. I'm running out of space, so I'm going to use my parallel symbol, but you can write the word parallel out. Or you can simply, these are your notes, so you can write them in the way you want to. Okay? All right. In the far right, top right. Now, geometric hieroglyphics number 2. What do these symbols mean? Both pairs of opposite sides are equal or congruent. And you make your notes say what they need to say, right? Okay? Both pairs of opposite sides are congruent. Geometric hieroglyphics number 3. What do these symbols mean? The opposite angles are congruent. And again, you use whatever symbolism you want to on here. You can write the word angles out. You can write the word congruent out. Okay. Next one. What does this geometric hieroglyphics mean? The bisected diagonals, right? So in a parallelogram, the diagonals bisect each other, right? Okay, so parallelogram has diagonals that bisect each other. The diagonals bisect each other, so they meet at the midpoint. They cut each other in half. Nope. We'll see. Okay. All right, bottom one. What does this geometric hieroglyphic mean? One pair of sides, right, is both congruent and parallel. If you want to say equal and parallel, that's okay, right? We have one pair of sides that is both congruent and parallel. One pair of sides is congruent and parallel. Nope, we're only doing the ones that are in yellow. The ones on the right. Okay. All right. Absolutely. The rest of them will eventually be filled in, okay, but not today. There's enough to do today with just parallelograms. Just parallelograms today, okay? And then finally, here's our last one. In this top middle, we have some hieroglyphics that have picture with x's and y's in the angle measures, right? And it says x plus y equals 180. So what are we going to write for this one? X and y are what kind of angles? How are they related to each other? They're supplementary, right? Because they are, and they're not opposite, they're consecutive. So our consecutive angles are supplementary. I ran out of space because I have a big marker and a small space. Okay, but you're writing in pen or pencil, so you'll be fine. Consecutive angles are supplementary. The angles that are next to each other in the parallelogram add to 180. They're supplementary. So far, so good? Okay. So keep this handy, okay? And we're going to talk about how we're going to prove things, right? And then we'll have a couple, 3 examples, and then away we go, okay? Nope, today is just watch, okay? So now we don't have to write something down because we just wrote it down. Okay, here it comes. So if I want to prove that a quadrilateral is a parallelogram, I either need to find out that we have 2 pairs of parallel sides, right? Which we just talked about. That's the definition of a parallelogram. Or I show that both pairs of opposite sides are congruent, right? That's a second way of showing it. A third way of showing that a quadrilateral is a parallelogram is that we take the opposite angles and show that they're congruent, right? A fourth way of showing it is to show that the diagonals bisect each other, okay? And then finally, a fifth way is to show that the one pair of sides is both parallel and congruent, and that's enough to make that quadrilateral a parallelogram. And our last way, we just did at the top, is to say, let's make those consecutive angles supplementary, then it has to be a parallelogram as well. Okay? So those are the 5 ways that we can prove a parallelogram, or quadrilateral is a parallelogram. Okay? So now, here's our first example. Okay? And you can just watch, or you can take out a piece of paper to take notes. It's your choice, okay? But if I give you something like this, and I want you to tell me whether or not it's a parallelogram, we have to come up with a strategy and explain why. Absolutely. Okay? So we have ABCD, right, is a quadrilateral, and we want to know if AB, the distance between A and B, is equal to the distance between B and C, and the distance between C and D is equal to the distance between A and D. Is that enough to make that a parallelogram? Okay, so Braden's drawing a picture, right? We always can see this better if we have a picture. So that's the first step. Go up there and draw a picture, okay? So now he's going to make his marks, right? Okay? So he's going to show us that AB is congruent to BC. Okay. So, Braden, what marks? So, which marks are you going to make to show that the distance between A and B is equal to the distance between B and C? Okay, so now, here's what we have to be careful of, okay? Guys, watch this. Here's what we have to be careful of. Hold on. A, B, C, D. Notice how he made sure. No, you're fine. He did label them A to B to C to D, right? So you want to go in a circle, in a circular fashion. Now he's marked AB congruent to BC, right? And now he's going to mark CD congruent to AD. Okay? Is that enough to prove that that is a parallelogram? And Kiara's shaking her head no. Why? You're correct. Why? Okay. Good. Exactly. So the opposite sides aren't the congruent ones, right? Make sense? So we just say, no, opposite sides are not congruent, so it's not a parallelogram. Does that make sense? Okay. So, yeah, we would have to change this. Or the way, okay? Okay. Now, here's what it would look like if we could draw it to scale. Okay? If I were making A to B congruent to B to C and C to D congruent to D to A, what kind of figure would I get? A kite. Okay? That's why this is not a parallelogram. The opposite sides are not congruent. Make sense? All right, so if you get a problem like this, thank you, sir. If we get a problem like this, we have to draw a picture first, right? Because pictures help us. Okay? Nice job. All right. So, next one. Who wants the marker? Someone else. Who wants the marker? Maya. Okay? Help us figure this one out. How are we going to set a value for x so that, and y, so that this is a parallelogram? Okay? What are we going to do? Absolutely. All right, so why did Maya set 24 plus x equal to x plus 6? Very good. Opposite sides have to be equal. So now that she's got an equation, she's going to get her x's to one side and her numbers to the other side, right? So she'll have a 2x on one side, and she's subtracting the not just one x, but you'll have to add an x. There you go. And it's very big when you're up there, so it's really hard to see it. It's disorienting and orientating until you figure it out. Disorienting. All right, so that's x. Okay. So who wants to be my next person and figure out what y is? Somebody else gets turn. Go ahead. Joey, go ahead. Okay, so Maya correctly found that x was 9, right? So now that we know x is 9, we're going to find out what y is. Exactly. Very good. So once we found out what x was, then we plug it back in for x and set it equal to y, because y is the opposite side of the 2x plus 3. All right, so we can do these, right? Okay. They're not hard. It's going to be hard when we try to keep it all straight, once we have more figures, more quadrilaterals to work with. Okay? All right, so this is what happens in the old world, okay? In the U.S., rather than fix things up, we just bulldoze it and start over, right? But in the old world, in a civilization that's been around, Rome and so forth have been around for centuries, right? They just fix things. They build on top, they remodel, and so on. So this is a door over in Europe, okay? And over time, the building has leaned sideways, right? So they fixed the door to make it open and close properly, and that's what this door has ended up looking like. A sideways door. Kind of something like out of Harry Potter, right? All right, so out of the wizarding world. Okay? So we want to know, how can we prove, okay, please, okay, how can we prove, or how can we know that angle S is congruent to angle U? Okay, so one pair of sides is parallel and congruent, right? So it is a, wow, can't write. A parallelogram, right? And opposite angles of a parallelogram are congruent. Okay, that's what we're looking for your rationalization when they ask you to explain. We can do these, right? Okay, because one pair of sides was both parallel and congruent, then that means it has to be a parallelogram. And once we know it's a parallelogram, opposite angles have to be congruent. Okay? Thumbs up, we're good? Okay, next one. Last one, or second last one. Okay? For what value of x is this quadrilateral a parallelogram? So what are we going to do to make this happen? Let's see how your handwriting is on the board. She can do it. She was already on her way to do it. Okay? Okay. All right, so we can do these, right? Okay, very nice. Okay? We can all do this. Be nice. Okay? All right, last example. Okay? So, we can give you 4 points. Okay? And we can ask you to figure out whether this is it's a quadrilateral, right? So we can ask you to figure out whether it is a parallelogram or not. Okay? Now, I know of at least 4 ways that you can show that it's a parallelogram. If not 5, right? Nope, let's talk about it. Okay? Okay? So it's hard. Here's the one that's hard to do. Opposite angles are congruent. We're not going to give you a protractor and have you measure it. Okay? So we're not going to use the opposite angles are congruent. But yes, we can prove that both pairs of opposite sides are congruent, right? So that means distance formula. We can show that they're parallel. How do we find parallel? Rise and run, right? Find our slope. Okay? Okay? So we can prove that both pairs of sides are parallel, or show that. Use slope. Okay? We can show that both sides are both pairs of opposite sides are congruent, right? I am. I know, it's I just worked 13 hours yesterday. I'm tired, okay? And then Okay, a third way would be to show that one pair of sides is both parallel and congruent, right? But do you want the shortcut?
I don't want a shortcut.
Kind of want the shortcut? This is going to take, okay, this is going to take 4 calculations, right? 4 calculations, right? If you're showing a pair of sides is both parallel and congruent, that's 4 calculations. But I can cut it down to half. Okay? Okay? Think about what is our last possibility, Maya. Absolutely. Okay? No, 2 midpoint problems is a lot less than 4 slope problems, right? Or 4 distance formula problems. That's the slope. Okay? So we can find the coordinates of the midpoint of BD and the coordinates of the midpoint of AC and show that they're the same point. Make sense? Okay? Guys, please, a couple seconds and we're done. Okay? Or you have to find y2 minus y1 over x2 minus x1 4 times. Or you have to use distance formula or Pythagorean theorem 4 times. This is faster. So with the Pythagorean theorem, we have gone down 2 and over 4, right? So 2 squared. Right? So I'm giving you a pass. I'm giving you an easier route, right? Maya gave you an easier route. We say, let's find the midpoint of segment BD and find the midpoint of segment AC. And when that's the same point, the diagonals have bisected each other, so it has to be a parallelogram. Make sense? No? Okay. Let's find the midpoint of these two. What's 4 plus a negative 2? Okay. 4 plus a negative 2 is 2. Divided by 2 is, and negative 2 plus a negative 2. And when we divide that by 2, so 1 negative 2 was the midpoint of BD. Okay? Thank you. Okay? 1 negative 2. Okay? Now, 0 plus 2 divided by 2. And 0 plus a negative 4. Negative 4 divided by 2. This point and this point are the same, so it has to be a parallelogram. Okay, last page. Here we go. Assignment. Okay?